In this last video on sums and differences identities, we're going to look at calculating the exact value of sine inverse of 2/3 plus tan inverse of 4. This can be done using the sum formula for sine, and we can rewrite this as sine of theta sub 1 plus theta sub 2. And that formula is going to be sine of theta sub 1 cosine theta sub 2 plus cosine theta sub 1 sine theta sub 2. And you could rewrite these cosine signs in different orders because multiplication is commutative. However, this is the standard generic formula for sum of sine angles. Now I'm going to break my page into two parts, and I'm going to calculate theta sub 1 and theta sub 2 with generic triangles graphed on an xy axis. If I want to find sine of theta sub 1 equaling 2 over 3, if I use sine of theta sub 1 equals 2/3, then I can sketch my triangle with theta sub 1 here, and sine is opposite over hypotenuse. So 2 is my opposite, 3 is my hypotenuse. I need to find the other side, which will be 3 squared or 9 minus 2 squared or 4. That gives me the square root of 5 as my other side. Now let's calculate tan inverse of 4. That means that tangent of theta sub 2 is equal to 4. This only happens in the first and third quadrants. I'll go ahead and just sketch it in the first quadrant. Here's my angle theta sub 2, and tangent is opposite over adjacent. I'll put 4 over 1, and I get 4 as my opposite side, 1 as my adjacent side. Clearly these triangles are not to scale. And then I need to find the hypotenuse. The hypotenuse will be 1 squared plus 4 squared, which will give me the square root of 16 plus 1, or square root of 17. Now that I have that information, I can rewrite my signs of angles in the sum formula for sine and replace them with the ratios given here that we just found. Sine of theta sub 1 plus theta sub 2 is equal to sine of theta sub 1, which will be 2/3, times cosine of theta sub 2, which is adjacent over hypotenuse, which gives me 1 over the square root of 17, plus cosine of theta sub 1. Again, that gives me adjacent over hypotenuse, or square root of 5 over 3. That's times sine of theta sub 2. Theta sub 2 will be opposite over hypotenuse, or 4 divided by the square root of 17. If I simplify this, I get 2 over 3 root 17 plus 4 square root of 5 over 3 root 17. The denominators match, which is super convenient because now I will have 2 plus 4 square root of 5, all divided by 3 square root of 17. I could leave it like this. Sine of theta sub 1 plus theta sub 2 is equal to the given value. Or I could rewrite my angle theta sub 1 and theta sub 2 as it originally appeared with the final value. I'm fine with you leaving it in this form here because it is exact. Multiplying by the square root of 17 in the numerator and denominator will not make it look much better. It will just get a radical out of the denominator.